go. Hello and good day, Algebra. We are covering CO49, which is multiplying polynomials. If you think back to our progression with polynomials all the way back in CO44, we started with just finding the greatest common factor of monomial expressions. We then talked about the difference between monomials and binomials and trinomials and polynomials, talked about how to write them into standard form. Then we started the operations. We did one objective on adding and subtracting. And this is now our third objective on multiplying, because there's so much that can go on when you multiply polynomial terms. Because it comes down to every term in the first expression has to be multiplied by every term in the second one, right? We started with a single term times a binomial, times a trinomial, times a polynomial here. This is back in 47 here, okay? And our task here was just, all we had to do was distribute that monomial into our parentheses. Nothing really fancy there, right? But then in PO48, we built up a little bit, and we said, well, what if we have two binomials? We're still multiplying each term in the first set by each term in the second set, and that's where we talked about 3 different ways to make that happen. Because the lines can get a little bit complicated if you're not careful with them, or if you don't like the lines at all, you've got the box method there. Okay. Now we're ramping it up one more time, and we're multiplying polynomials by other polynomials. We're multiplying a binomial times a trinomial, or we're multiplying a trinomial times a trinomial here. Think about how these lines are going to get chaotic if we're distributing this 3x cubed into each term in the other set. Then we have to go back and take our 4x squared and distribute into each term in the other set. Then we have to somehow find room to take our negative 5x and distribute this into each term in the other set. The lines get pretty crazy. Okay? So instead, we are going to focus only on the box method, which keeps things organized. It eliminates the lines. Okay? And I think that since it's what most of you use on PO48, it's going to translate really well to CO49. Right? So the first one, 7x minus 4 times 2x squared plus 4x plus 1. What size box are we going to have to make here? A 3 by 2. And it doesn't matter if you've got 3 openings going down the side, 2 across, or 2 by 3, or whatever. Typically, I like to make them so that the longer term is on top, just for space purposes. Okay? But again, don't make this too small. You're going to be writing terms with negative signs and exponents. Make it sizable. Okay? And then down the side, we put our 7x and our negative 4. Right? The 2-term expression has to go down the side where we have the 2 openings. And then our 2x squared, 4x, and 1 is going to go across the top. And from here, it's pretty much exactly what you did in PO48, right? Where each box, each square, is the product of the 2 terms that intersect. Okay.
If you already have an exponent on the top one, would it make it 4?
So 2x squared times 7x, this kind of goes back to PO47. How do we multiply 2x squared by 7x? Because you're right, now we've got larger powers here. We have more expressions. Not 7x squared, 7x. How do we multiply 2x squared by 7x? Abby?
14x.
So the coefficients get multiplied, right? 2 and 7. Multiply to make us 14. And then what do we do with the exponents? You add them. And remember, if it's just x, it has that hidden power of 1. So 2x squared times 7x, 2 times 14 gives us, or 2 times 7 is 14, and x squared, we add the powers, 3 plus 2 is 1. We get 14x cubed. And if we think about this in expanded form, it makes perfect sense. 2x squared is 2 times x, and we're multiplying that by 7x. Well, how many x's do we have there? All being multiplied together. 3 of them, right? 2 times 7 is 14, 3x is total, x cubed. Why? Sure. might be your last trip out of the room though. I'll check. Yeah. Are you sure?
Not mine.
We have a month and a half left of school.
Alright. How many do I have?
Think twice.
Are you sure, like, what happens if we leave?
He's gone. Okay.
How many
So
do I have?
I can check later on. 2x squared times -4. The -4 doesn't have an x, so this is just going to be -8x squared. We only have to multiply the coefficients. The x squared just kind of tags along, nothing to multiply with the -4. 7x times 4x is going to be 28x squared. They both have an x, so two of them is going to be x squared. -4 times 4x is a -16x. 7x times 1 is 7x. And -4 times 1 is our constant, -4. Okay? So very similar to what you've been doing in PO47 and PO48. Combining these terms by multiplying. Now, just like with the box method in PO48, what can we combine? We've done the multiplying. What like terms do we have, Shay?
28x2, -8x2, and -16x, 7x.
Okay, good. Anything that has that same variable, the same power, can be combined. In this case, we got -8x squared with 28x squared, and then -16x and 7x. This 14x cubed and -4, they don't combine with anything. Right? There are no other like terms with them. So our answer, 14x cubed, is going to come down as is. If you have 28x squareds and you lose 8 of them, you take away 8, how many x squareds do you have? 20 of them. Okay? So plus 20x squared. You have -16 x's, you add 7, how many x's do you have? -9. So -9x. And then our constant also just comes along since there's nothing to combine that with. Okay? Where kids tend to get tripped up with this, because unfortunately it's a lot of calculations here. If you make a mistake in one of the boxes, it's going to mess everything else up as far as what you can combine and can't, everything like that. So where kids tend to trip up, so watch out for this. Something like 7x times 4x, they just put 28x. They forget that x times x is where we get that x squared there. Then, when they go to combine like terms, they'll take like 28 minus 8 and put 20x to the fourth. They add the powers. Or they'll subtract the powers and put x to the 0. Remember, when you're combining like terms, as we are here, that variable doesn't change. That variable stays the same. Okay? Whoop, Wyatt, looks like you're getting bounced. Or no, sit there. Okay. Questions on this one? Never mind. Okay, let's do a 3 by 3. Let's do the one right below here. 3x cubed. Actually, let's do this one here. 9x to the fourth minus x cubed plus 2x squared, and then 5x cubed plus 7x minus 10. This time we need a 3 by 3 box. And again, don't make it small. Okay. Total, we got 9 squares. I think it's actually where the idea for 9 squared came from. Was doing the box method here. 9x to the fourth. Negative x cubed. 2x squared. This time it doesn't matter which one goes across the top, which one goes down the side, because they're both 3. But we'll just put that one across the top. And then 5x cubed, 7x, negative 10. Don't forget that negative sign, the negative 10. If you put a positive 10 here instead of a negative 10, it's going to throw off the sign of everything. We're just going to throw off everything else when you try and combine terms here. Okay? So before you start, just do a double check. Make sure you've got every negative sign correct, every exponent correct, okay, that you transferred it correctly. And then you just start to multiply. 9x to the fourth and 5x cubed. What does that give us here?
45x to the...
Good. Coefficients multiplied. 9 times 5 is 45. And then 4 plus 3 is x to the 7th. Next box over, 5x cubed times negative x cubed. And we run CO49 right now. 5x cubed times negative x cubed. Remember, this coefficient here is really a negative 1.
Negative 5x to the 6.
So negative 5x to the 6th. And then the last one, 5x cubed times 2x squared.
15x to the 5th. Wait, 10x to the 5th.
10x to the 5th. Good. Okay. Second row, 7x times 9x to the 4th. 63x to the 5th. Middle square, 7x times negative x cubed. Negative 7x to the 4th. This middle row can be tricky because remember that x with that 7 has a power of 1 even though it isn't written. Right? So we always, whatever our exponent is up here, we'll always be adding 1 to it when we put it inside the box because we're adding an x. Then 7x times 2x squared is 14x cubed. Then the bottom row, that negative 10. Negative 10 times 9x to the 4th is negative 90x to the 4th. Exponent doesn't change here because there are no x's with the negative 10. It's just a constant. Negative 10 times negative 1x cubed is a positive 10x cubed. And negative 10 times 2x squared is a negative 20x squared. All right. So if you understand, all the way back to CO10, you understand PO47, you understand PO48, you can see there's really nothing new. It's just bigger, okay? Our expressions just get longer. So, what can we combine? Anything with like powers, right? Do we have any other exponent of 7? No. So that's by itself. Whoops. I'll do that in black. Do we have any other exponent of 6? No. So that's by itself. Exponents of 5. Notice that this time they're not right next to each other. Why is that, you suppose? Right, in our previous example and in everything from PO48, what we could combine was right next to each other. They were straight diagonal. Here our x to the 5ths aren't. We've got one way up here and another one down over here. What do you think accounts for that? Ooh, you gotta be careful not to, with your circle, accidentally take away a number here so you miss it, the 10x. What do you think that is? Why aren't they right diagonal this time? What about our original expressions might account for that? Notice that this one here, x cubed, it skips an x squared term, right? It doesn't go 3, 2, 1 constant. It goes 3, 1 constant. When you skip a term, it's going to kind of shift where your like terms are. Okay? So just be aware of that. Our x to the 4th, we can simplify these. These are right next to each other there. We also have x cubed. We can do that. They're right next to each other. Oh, didn't do that in green or black. They're right next to each other there. And then we have our standalone x squared term, which can't be combined with anything else. So, our final answer. I'm going to start way over here. 45x to the 7th. Our term with an exponent of 6, which we couldn't combine anything with, negative 5x to the 6th. Our x to the 5th terms, how many total x to the 5ths do we have? 73, right? 10 from here, 63 from there. Total, that is 73x to the 5th. I'm still going to run out of room. How many x to the 4ths do we have? Pay attention to those signs. We have a negative 7, and then we subtract 90 more.
Negative 97x to the
Negative 97x to the 4th. How many x cubes do we have? 24 of them. Positive 10, positive 14 is 24x cubed. And then just squeeze it in here. Whoop, our negative 20x squared, which can't be combined with anything else. Wow. There you have it. Okay. And then, guess what you can do in Algebra 2? You put an equal sign on here and have this whole expression equal something and then solve for x. Yay! We don't do that here. We are done here. This expression does not have an equal sign, right? If there's no value, we can't solve for the variable. Because in order to solve for the variable, we have to know what it equals. If I just said, x plus 12 and said solve for x, you can't possibly do it. There's no value, right? So in Algebra 2, you're going to throw in an equal sign, give this a value, and then solve for x, but I'll let your Algebra 2 teacher worry about that. Yeah? How would you, it involves a lot of what's called factoring, which we're going to start to dabble in 51 and 52. So it's coming up, but we're going to stick to only factoring trinomials, not polynomials such as this. But it involves a lot of factoring. Okay, questions, comments, concerns, complaints, compliments, congratulations, or criticisms?
Congratulations.
Thank you, Johnny. Anybody else? It's a lot. Okay? The math isn't challenging per se if you've been keeping up with the other objectives that we've done, particularly 47 and 48. Okay? But it is quite a bit of work. Obviously, work must be shown. The box method is what I want to see. And for tomorrow, you have 1, 2, 6 to do.
We don't have that.
Oh, yeah. So the binder's printed funny. Flip another page over. And that's where they are. I don't know, one page got like split around or something. Okay. Actually, you know what? In the spirit of 1,000 Christmases, of the 6 you've got remaining, pick 4. Okay, 4 of the remaining 6. How about that?
Yeah, I just did
4 of the remaining 6, and you do need to do the time for review. Folks, I don't want there to be any questions tomorrow. So of the 6 we have not done, we did 2 of them on the first page, so there are 2 remaining. And there are 4 of them on the second page, so total of 6. Of those 6, pick 4 of them to do, but you must do the time for review at the bottom. Okay? So 7 total questions. 7 total questions, 4 of the big box, and then all of the time for review. Any questions on what you are to do for tomorrow? Okay, you've got 6 minutes of quality working time now. That is how you math. Like and subscribe.